Hi everyone, today we are going to do this example. We have an object that starts at point O, that means the origin, moves in a straight line. So let's begin with a diagram. I'll just get my drawing ready. So we have a straight line, it's like an x-axis, this is the origin, and then positive would be this way, negative would be this way. And, we just mark this off cross in positive and then negative numbers. So, what are we told? We're told that v equals 2t plus 3. We have to find the position. This is important here too, that it starts from rest at it starts from point O. What does that tell me? Well, that tells me that the object is here. In other words, x at the original moment when we start observations, x is the value of 0 meters. Now, we were given v, but we have to find x. X is the integral of v with respect to t, and there'll be a constant when we integrate. So let's substitute for v. We'll put 2t take 3 dt. So the 2 remains. We increase the power on the variable to squared and we divide by that new power. Then 3 integrates to become 3t plus a constant of integration. This is x. Now, obviously, we would be able to cancel the 2 here and here. We will evaluate. We will go when so I have a coordinate value for t and x. When t is 0, x is 0. Substituting, we would have 0 equals 0 squared plus 3 times 0 plus c. That seems to show that c equals 0. And so our conclusion then is that x equals the formula t squared minus 3t plus 0. That's our equation for x, and that's part A. We have to find the position after 3 seconds. That's going to be letting, we want x when t equals 3. So we write 3 squared minus 3 times 3. That's 9 take 9. That's 0 meters. Quite straightforward, that part. Part C, find the average velocity in the first 3 seconds. Well, an average velocity is a change in the position over a change in time. This is deltas, so it's an actual finite change. So that would be x at 3 seconds minus x in the original location, and it's dividing by the difference in time would be 3 take 0. Now we saw that both the original and 0 divided by 3, so the average velocity is 0 meters per second. Seems unusual, but we'll figure it out. Then find the distance travelled in the first 3 seconds. All right, this is getting a bit confusing. So what I'm going to do is I'm going to take that equation and graph it on my calculator. Now we would be able to graph this without, but this is quicker. Now, of course, the calculator uses x, but our pronumeral is t, so we'll still get to see what we need to see. Let's go back a bit. There you go. Let's go up a bit. Now that's good. If I trace this around, then where am I? Oh, it's coming back. Keep clicking, it'll eventually get back into view. Here we are. So when time does equal 0, then x equals 0. Remember, this is a time axis, and vertical axis is position, so that's fine. And there's the one we found before. Now, what we've got to do, I just have to press escape to get out of trace, I think. What we've got to do is figure out the distance travelled. That's what they said, weren't they? They want the distance travelled in the first 3 seconds. Now, distance is how far you've moved across the ground. So it starts there. It moves backwards to start with. It comes momentarily to rest here, and that's a key point. Let's do a GSolve minimum to find that point. So that point is 2.25 or 2.25 meters back, and then it moves forwards again. Right. So let's see if we can work out the distance travelled. So distance, it started from the origin, it moved back by 2.25 meters. We don't worry about forwards or backwards for distance, so it's just the absolute value. And then it moved forwards by 2.25 meters back to the origin. So it moved a total distance across the ground of 4.5 meters. Finally, the average speed. Now, speed equals distance over time, not displacement. Distance was 4.5, time was 3 seconds, so we have an average speed of 1.5 meters per second. And that's how we do that one. Thanks for watching.